Hello everyone, welcome to lecture 2 of the course Computer Fundamentals and C Programming. So in this lecture, I'll be discussing about computer architecture, little bit about that. I'll be discussing about the overall operation, what a computer actually does and how computer does that operation, very briefly on that. And most importantly, when we perform a task on a computer, we generally have certain programming languages. Using those programming languages, we transform the program or the work to be done in terms of certain steps or you say program. How this entire process happens, that from starting writing a program, then executing it in a computer. So you need various softwares for that. One is called assembler, one is called compiler. We'll be looking into all these things in this lecture. In this brief lecture, let me give you a brief idea of what exactly we'll be discussing. Now, these are the things that I'm going to discuss. Computer architecture, hardware and software. You know what is hardware, you know what is software. I'll briefly tell you a little more about it. The main task of computer, I have always told you from the very beginning, to solve certain problem. Let's say we cannot do it manually, something which cannot be done manually. It may be done manually, but it will require a huge amount of time. So to reduce that, we perform certain tasks, we solve certain problems using computer. So we'll see that what all problems could be solved easily using computer. Number system, there's an entire lecture on number system later, but I'll be giving you very briefly what is number system, what is nibble, what is bits, what is byte and words, and how computer uses all these things and why it is required. And then, as I told you, for solving a problem, what we need? For solving a problem, we basically need a particular language, a programming language, using which we can transform the problem into that particular programming language, convert that to, let's say I wanted to add 10 numbers. I can add those 10 numbers easily by hand, but I can do it manually and I can do it using a program by writing, using a programming language by writing a set of codes, writing a set of codes which translates into adding sum of 10 numbers and we get the result. I will tell you that what is a low level language and what is a high level language. You have to make one thing clear, that computer can only understand 0 and 1. Why? Computer is built of transistors ultimately. You will see that what is a chip? Chip is built of certain circuits. What is a circuit? Circuit is built of certain gates. And what is a gate? Gate is built using certain transistor. So we boil down everything to a transistor. So, and a transistor is basically kind of switch. It will just understand 0 and 1. So everything needs to be converted into in terms of 0 and 1 for the computer to understand. So that is why low level languages are very, very important. But writing programs using low level language is not easy. So we actually tend to write programs, write our entire thing in a high level language. And then we have an intermediate program that converts our high level language into a low level language, which is understood by a computer easily. Okay, these are the following things that we are going to discuss in this lecture. And let us revisit this diagram. We will be revisiting this diagram time and again. And this is the block diagram of a computer. We have input device. We have a central processing unit. You know, a central processing unit is having two main components. One is control unit, another is arithmetic and logic unit. Arithmetic logic unit actually performs the arithmetic and logic operation. So basically, when I say I'll add two numbers, then the adding of two numbers will be done using this ALU. But think of what all steps are required for adding these two numbers. Everything, the steps that are needed to be generated by a computer is done through control unit, that is CU. Okay, so we will be discussing all these and you will be learning about more of all these things in a different course called computer architecture. But this is the overall idea of what a CPU does. It is divided into two components, two important functional unit. One is control unit, one is ALU, and they have their different purposes. Now, as I told you in the first lecture, everything is programmed, right? So as you know that we get up in the morning, we start doing, like, we know that we need to brush, we know we need to take bath, then we eat and everything. A program is already stored in our mind, you know. So based on that, we work. Similarly, you need to feed information to a computer, so it has to be stored somewhere, and then only you can perform that task. So memory is the place where instruction and data both are stored. But what is main memory, what is other storage peripherals, etc. We'll discuss about this in little detail in the next lecture when I discuss mainly about memory. But for now, you understand that memory is a place where we store all these things. When you have to perform a task, uh, the instruction and data are stored in memory, and it is brought into the processor one by one, and it gets executed. This is how entire thing works. Similarly, like, everything is stored in our mind, that we need to get up in the morning, we need to brush, and we need to go to bath, and we need to have a breakfast, we need to go to office, etc., etc. In a similar way, everything should be stored in main memory, and then the central processing unit, or the CPU will bring the data or instruction one by one, and it will perform the task. And then finally, the data is transferred to output device. So this is basically the overall function of a computer. Let's move on. What is computer architecture? As I told you, you have a separate course on this, but why do we need architecture in the first place? Think of building a house. When you build a house, you first need to have an architectural plan, right? How many rooms you will be having, where you will be your bathroom, where will be your dining room, where will be your kitchen, how efficient you can make it such that you don't have to have too many water passage pipes, etc., etc. There are many ways to optimize it. You know, in a similar way, in a computer, the architecture is basically the various components, CU, ALU, how the ALU is built. Inside ALU, there are many components, input output unit, memory, how all these components are interconnected such that we get better uh, performance, you know, performance in terms of speed, performance in terms of energy, efficiency, etc., etc. And this computer architecture basically it is the programmer's view of the computer system, which is called the instruction set architecture. So every computer has a defined set of instruction that it can execute, and we as a programmer knows that, okay, these are the set of instruction that this computer can execute. When we when you when we write a program, of course there is a compiler which does that, but the compiler needs to know what is the instruction set architecture. So this is how things goes on. So this is an important aspect, and you'll learn this subject separately as a different course altogether. Let's move on. What is hardware and what is software? Think of your mobile phone. You know, it's a hardware, right? Let's say you do not have an Android system or iOS loaded into it in your mobile phone. Maybe it is an Android-based system, or if it is a Mac-based system. If there is no software within that system, how it will interact with the user? So basically, you need software which should be installed in in a hardware so that you can communicate it better. A hardware is just some piece of uh, material kept aside, unless and otherwise you install a software within it. So you need an operating system which bridges the gap between the user and the hardware of the computer. That is the software which we need. We'll talk about various kinds of software. One kind of software is the system software, which is needed for your operating system. And then there are various applications. This is an application. This is an PowerPoint presentation that this is an application. This is basically called as an application software. But the operating system is a system software. So there are various classification of software because and what is a software? It is nothing but a piece of code. That's it, is a software. But hardware is a component. Some people use certain materials to build that hardware. And software is something which will run on that hardware, but it is just a piece of code written by a computer scientist or computer programmer. So this is how we'll discuss more about hardware and software. And this is basically a layered view of an operating system. Now, layered view, we have hardware. As I said, this computer is your hardware, right? CPU with monitor, with your mouse, with keyboard, etc., etc. A software is running inside it, and that is how we are interacting with this hardware. So the user is interacting with the hardware through this operating system, through this software. And of course, there are other softwares, application softwares on top of it, which is required to run various applications. And that is why how the communication and everything is happening today. Like I'm also discussing with you, and you are listening through many applications that is written, but on what it is running? On a hardware. This is how it works. Okay, let's move on, and now we discussed a little bit about why we need computer. I already discussed this in the previous lecture, but mainly it's used for problem solving. A computer can be instructed to carry out a well-defined task. As I said, you have to instruct computer everything. And for instructing those things, those should be stored in memory. From the memory, each instruction is brought into the processor and it is executed one by one by one. Okay. And what is a program then? Nothing but a set of instructions to carry out a task. Okay. And these instructions are specified using certain programming language. In this course, we will be learning C. And if you learn C, you will see that you will be able to learn any other programming language by yourself. But learning one programming language is very important. And so we are learning C in this course. Now, any programming language, when we say C or Java or you say or any other programming, C++, etc., etc., Python, any programming language needs to be converted into a machine level language because machine always understands 0 and 1. I've told you. So either we write a program in any hardware language, there should be certain software again sitting in between these two, programming language and the hardware, to convert that into machine level language. And what is machine language? A language built using only zeros and ones. We'll look into this in greater detail. As I told you, I'll be discussing about number system in a separate lecture altogether. But this is how our decimal number system is, which you are already accustomed with. It is 10 digit, starting from 0 to 9. And every digit position has a weight, which is a power of 10. So what is 234 if you convert it? 4 into 10 to the power 0, 3 into 10 to the power 1, and 2 into 10 to the power 0. So basically 4 power is 0, 3's power is 1, 0, 1 and 2, and so on. You can increase it as the number increases. And then you add it up, you will get this number. Similarly with binary, we'll discuss in greater details later. Okay? And there is a concept of bit, nibble, byte, and word. And today's concept, we only use word. But we also need to know all these things. Why? Because our computer is byte oriented. It accesses word at a time these days, but we need to understand the concept of byte, etc., etc. Again, these things will be discussed in greater details in various courses that you will be learning in this entire BCA course. So bit is basically a single bit, either 0 or 1. Nibble is a collection of 4 bits together. Byte is again a collection of 8 bits together. And word, it depends on computer to computer. It could be 32, it could be 16, or it could be 64, or it could be 128, but always a multiple of 2. Fine. So this is how it works. I already discussed about this thing, classification of software. There are two categories. One is application software, one is system software. System softwares are basically helps in running other programs, compiler, operating system, and everything. So operating system is a huge set of code. You know, the Microsoft Windows operating system, or the Linux operating system, or any other operating system. It's a huge set of code to which allows other programs to run on top of it. But everything is run on this hardware. Hardware is fixed. You load a different software into your hardware such that other programs could be done easily and we the user can interact with it. And application software, you anything you do it in your computer, any software you install in your computer is an application software basically. It's either editor or financial accounting thing or mathematical toolboxes like other things. Anything is other application software. Now, this is something I wanted to discuss, and then probably I will left the things to be discussed in the class itself. Uh, Now, we write programming in a high level language, C or Java or anything else. But as I told you, the computer can only understand 0 and 1. These programs must be converted into low level languages, like language which is 0 and 1. So everything what we write must be converted into this low level language, which is called basically machine language or assembly level language. We'll see in greater details what is a machine language, how it gets converted into that, what is assembly level language, why do we need that, everything in course of time. Now, high level language is closer to the user. Any if you write a programming in C or C++ or Java or any other Python or any other language, you see it's much more convenient to write. I'm not writing something in terms of zeros and ones. I'm just writing a program. But with other programs sitting somewhere, to convert to that. Okay, so this is high level language. High level language is much higher level and which is easier for a user to understand, but not for a computer to understand. Computer only understand low level. So here ends my broad overview of lecture 2, and I hope that you will be enjoying the class where I discuss more about all these things. Okay, thank you.